F is a function mapping from W to W defined as f of n equal to f of n equal to n minus 1 if n is odd, equal to n plus 1 if n is even. So that means if we start from 0, for 0 it will be n plus 1, 1. For 1 it's this is the input a n value and this is the output f of n value. So if f is n is 1, then it becomes minus 1. For 2 it's again 2 plus 1, 3, and sorry, this is 0. So similarly here for 3 it's 2. So for 4 it's 5, whereas for 5 it's 4. So if you go on like this, then we see that all the odd numbers are getting shifted backwards by just 1 unit, and all the even numbers are getting shifted by 1 number, thus spanning again from 0 to infinity, which is a whole number case. So that means this we just showed that it's spanning, sorry, f of n is spanning the whole numbers, but that's not the question asked here. Here we are asked whether f of n is invertible or not, and to find the inverse of f, that is f inverse. So how to say that given f function is invertible or not? One thing is we are supposed to show what we can show is f is both 1 1 and onto. If it's both 1 1 and onto, then we can say that f is invertible. And how to show that it's 1 1 and onto? Before showing that it's 1 1 and onto, let's try to understand what 1 1 and onto mean. So let's begin. What is 1 1? So 1 1 means that for any two different inputs, n1 and n2, if n1 not equal to n2, then we get f of n1 not equal to f of n2. Here we can say that no two elements, no two numbers, let's say any two numbers is and this, they're not having same output. If we take any two random numbers, we are not getting the same output. That means no two elements are having same images. So that means given function f is 1 1 in nature. So f is 1 1. And for onto what we need is if f maps from a to b, then for the function to be onto, the whole of b must have a image in a. That means all the elements in b must have a pre-image in a. So that, or otherwise we can say that range must completely exhaust the set b. So range of f of n must completely fill the whole numbers, which is what I showed you when we are starting to when we just read the question. So here I just showed that in the image fn set, it's spanning to the whole of all numbers from 0 to infinity. Thus b is totally exhausted by the range set. That means given function f is onto in nature, and it's both 1 1 and onto, both 1 1 and onto. So that means f is, so that simply implies f is invertible in nature. And how to find inverse? Given f of n is equal to n minus 1, this is when n is odd. So that implies n minus 1 is equal to y, and we know that if let n of n minus 1 equal to 5, let it be there, and f equal to n plus 1 if n is even. And now we get let's say for the condition for inverse is, let's say g of f must be equal to f of g, which is equal to I. So that means here g of f of n must be equal to n. So if n is odd, then this is g of y is equal to n, where n is equal to, that implies g of y is equal to y plus 1 when n is odd. When n is odd, we get y plus 1. But we also know that whenever n is odd, we will be having y as even. So whenever y is even, we get g of y equal to y plus 1. Similarly, the other case, y minus 1, whenever y is odd. So that means simply g of, if you have y and if you have g of y, you simply get, if it's 0, it's again, if it's even 0 plus 1. If it's 1, again we get, this is minus 1, 0. 1 minus 1 is 0. If it's 2, then we get 3. If it's 3, we get 2. So if you go up and check back, here this is y. So this is y. So g of y will become, for 1 it's 1 minus 1, 0. So we're just going back to this place. For 0 it's plus 1. For 3 it's 2. So we are just getting the inverse of everything. So function f is inverse of itself. As we can see, we know that here just the same case, f of n is equal to n plus 1 when n is even, when n is odd, and similarly is equal to n minus 1 when n is odd. Here it's when n is even, and there when n is odd. So this is even, just as in the case of g of y. So f is inverse of itself.